Please welcome a partner session with Helm.ai.
All right. Is everybody nice and relaxed after that break? Oh, yeah. We're here to review Walter Isaacson's book. I'm just kidding. On the stage with me here, he currently leads neural interface development at Meta. Before that, he was CTO of Voyage that was acquired by Cruise and worked on a number of projects in sensors and perception that he can't talk about for the US Army Research Labs, Department of Defense, and most secretly, the autonomous car project at Apple. Gary, so that's Tarian Zai. Next to him is a partner and global automotive sector leader at KPMG. He has spent the last 17 years dedicated to the automotive industry with a number of high-profile transactions for Ford and Chrysler, and collaborations with Volkswagen, Peugeot, and Fiat. He has also published a number of groundbreaking papers on self-driving cars, connectivity, and mobile demand services. Gary Silberg. Thank you. And finally, we have co-founder and CEO of Helm.ai, focused on scalable deep learning technology for autonomous driving and robotics. Helm has already gotten a lot of attention from major OEMs like Honda. And Vlad previously served as the founding chief scientist at SIP Security, which was acquired by Netscope. After earning his PhD in math at Berkeley, an impressive academic career during which he published over 20 papers in applied math and machine learning, earned several rewards, and an MIT faculty position. And I'm Vitaly Golub, your moderator. After the last 10 years on the dark side in corporate and investment banking, I'm actually back in the CEO seat myself with a new startup that's I'm going on stage called Sophie Labs, the cross-section of AI productivity. So we're talking about autonomous vehicles, and we have a very short time, so we'll get right into it. What's the difference between building a dedicated robotaxi business versus autonomous private vehicles?
What's the difference between building a dedicated robotaxi and fully autonomous? And with the robotaxi, we push the button and magically Uber and Lyft would show up. Early on, that was very robotaxi. We push the button.
Now, being a robotaxi, which we have here in San Francisco with Waymo and Cruise, but the dirty little secret that you don't know is how much hundreds of millions of dollars did Uber and Lyft have to spend on marketing to get the customer, to get them to download the app. This is massive. And I think it's, in our industry, I love the tech. I'm with all these brilliant scientists here, and I'm a wannabe physicist. But I think the industry thinks it's all about the cool, sexy tech. But at the end of the day, all of you as consumers, why are you going to buy or download that app, and how am I going to get you to do that? And I think that will be the crux of that business model versus the personally owned one, which obviously when you own it, it's yours. And the economics of that are a lot different, and eventually when that comes level 4, and I'm sure Vlad will talk to you about. But so they're distinct business models, and the profits, the economic rents that you can get on those are completely different. And depending on where you sit in the ecosystem, I'd like to get my transaction fee. It'd be the tech player, I think would be good. This guy might be doing pretty well going forward.
Very nice. Yeah, I mean, it's something that doesn't get talked about enough. Everything gets put together where we have kind of in one sentence we talk about autonomous taxis and personally owned vehicles, but they're very different business models.
Completely different.
So, thanks for that, Gary. So, Tarian, there's been a debate whether autonomous vehicles really need any other sensors besides cameras. As our sensor expert on the panel, how do you see it?
Yeah, I mean, I think it's a very interesting question. It's actually one of these old questions that sort of, I think, almost like hasn't gone away since the time that I was doing AV. So my belief is that, you know, for inference, I think you can get away with cameras. I think that, yeah, for me, it's as simple as that. But the debate has been raging on since the beginning days of AVs. And I think for good reason. I think like a lot of the algorithms back in the day maybe weren't as good as what we have now. So when it comes to inference time, I think that you can get very, very far with, you know, with vision. Now there are arguments about like adding some other things, like for example, things around sound and things like that for emergency vehicles, and I think that's also quite valid. But for inference time, I'm gonna stick to this and say that vision is the way to go.
So you're in the vision-only camp.
For inference, I think that's pretty accurate.
So explain for the audience, what do you mean by inference?
Yes, inference is basically when the car is out in the field, for example, right? I think that you have a lot of information from cameras, right? As long as you have 360 views and things like that, right? Training might be a different story. I think there are different schools of thought on that. Do you train only with vision? Do you do things around multimodal sensory, training to sort of augment those different modalities? I think there are different schools of thought on that. But I think that once you crack that, I think you can get very, very far with vision. And that's actually good news because from a sensor perspective, they're very cheap. Cameras are just becoming cheaper and cheaper. Sophisticated systems like LiDAR systems, I think they're very powerful, but the cost is extremely enormous, right? And so I think that inference time vision is the way to go.
Do you think LiDAR will ever get to a point where it's cheap enough to put on every vehicle?
Maybe, but why, right?
Yeah.
I mean, if you have cameras that are already cheap, and look, cameras are also a very, very information dense sort of modality, right? It's extremely dense as far as the information we get from the scene.
Yep.
Right? It's also a very natural modality. We understand that there's a lot of history behind it and things like that, right? I think there's uses for LiDAR systems. I'm not saying that there aren't. But from a cost perspective, from an information density perspective, from the algorithms that are being developed against one modality, I think it's hard to beat vision for inference. So
certainly if you got to choose one, vision would be it.
if I had to choose one, I'd go with that.
Yep.
But like I said, I think there's maybe room around other modalities when it comes to training, and that's a whole different story. But for inference time, I think that we're good to go. Yeah.
Great. So Vlad, we've been hearing from a certain someone that full autonomy is coming this year for a number of years. And why are we still waiting? What are we missing?
Yeah, sure. Well, so I think that those claims have been made by a lot of different companies, right? There are a number of bottlenecks to get to fully autonomous driving. You can kind of break it down into a few. So on the AI side, of course, L4 is on the very cutting edge of what AI can do. But there's certainly a path forward to training neural networks that are accurate enough to actually achieve what's needed. So that's not necessarily the bottleneck. But there's two other things. So firstly, there's a validation component that's very important. You have to actually deploy on enough cars to be able to claim that the level of safety is adequate to actually take full liability for an L4 deployment. But that can be achieved on consumer cars and mass production programs. Really, right now, the fundamental bottleneck is effectively on the cost side, right? So if you look at the actual stack and what's required, there's then a sensor question, but I mean, as Taryn pointed out, and I agree that vision really is the key sensor, and that's really kind of the only kind of information complete modality you're going to get that can technically understand everything. Like you're not going to be able to solve corner cases, certain corner cases with LiDAR or radar, for example. You couldn't. It's much harder to build a system based solely on those. But there's also the compute aspect, and that actually ties into vision. So because vision is the bottleneck to actually solving certain corner cases, at the end of the day, you have to have powerful enough neural networks. And so in order to have powerful neural networks, you have to have pretty substantial compute platforms, and that comes down to cost. And if you kind of look deeper at examples of kind of L4 systems that are out there today at a small scale, if you kind of add up the costs of the compute stack, the sensor stack, the HD maps, the teleoperation, all that stuff, it's just so much cost that it doesn't make sense to scale. So that's really ultimately the bottleneck. It's that trade-off between cost and safety that isn't quite there yet.
Are we getting closer on the compute that you can put in the vehicle and afford it?
Well, I mean, compute certainly is improving every year. That's for sure, and it'll certainly get there. But yeah, I mean, it's going to take some time, and it ties into the validation question, right? Because without doing the full-scale validation, you don't really know exactly where you are. So you kind of have to. You can't necessarily assume a priori you know exactly how much compute is required. You kind of actually have to deploy at a sufficient enough scale and capture that information to truly assess what where the bottleneck is on the compute side.
Great. Gary, back to you. We've seen Cathie Wood and others put a lot of valuation towards autonomy right, towards the future potential of autonomy, whenever that really comes. How do you think full autonomy will change car ownership and transportation in general?
Well, let's take on the big question of the valuation and the economics. It's huge, okay? It's really big. The question is, who gets it and how should you think about it? I think there's a huge advantage to first mover if it works, according to the technology, if it works. And that's the big, I'll let these scientists prove it out and make sure it does. But I'm the optimist side. So let's assume it works for a second. Tesla has approximately 4.5 million vehicles on the road today, getting all the massive sensory data through optics, through cameras today. And then at some point in time, they're going to sell 2 million cars approximately next year, I think is their number, 1.8-ish. That'll be 6.5 million of data. And if you remember when ChatGPT came out, it was like nothing, 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 and then all of a sudden it was there. It was like, oh, and they got it. If you've ever looked at like AlphaGo, when they beat the best Korean Go player in the world, the second version of, it was an amazing moment. David Silver tells a great story on that from DeepMind, but the next version of AlphaGo, I forget what they called it, beats the old version 1,000 to 0,
Yep.
okay? And once you got it, you got it.
Once we have takeoff, it's...
Yeah, and so with Tesla, for example, they can distribute that automatically to the entire fleet like that. And so I think the economics, to me, are incredible, potentially for Tesla with the first mover advantage. If it works, they could be worth a lot of money if that works like I described. But it might, who knows? This is a question of nines and getting it to the next level. But I'm optimistic. The other example I would give you, more to home, what's another great first mover advantage? Well, Tesla figured out the charging stations, right? The superchargers. And I don't know if you've been paying attention, but they've got the best spots, the best charging, the best reliability, and this little company called Ford Motor Company, 2-3 months ago said, you know what? All Ford owners with electric vehicles we got an agreement with Tesla to use their charging stations, right? First mover advantage. And then this little company called General Motors followed, and then there's been this avalanche. So I think what could happen, why Kathy Wood might say this, is like, if they get it first, what are you going to do if you're another OEM and you don't have the technology? You're going to have to get it from Vlad or others, but Tesla could be in a very powerful position at that point in time. The consumer, you're going to have to pay for it. So I don't know how, they talk
You've
about...
already paid $15,000.
Yeah, I already did for my FSD, and damn it, he dropped the price already on me here, so I want my refund. But but I think the consumer will have to pay for it.
Well, also, ChatGPT, though, and AlphaGo are both, offline applications, right? That's the point, is that their compute is not an issue. So, and again, I don't think the AI software itself is necessarily the bottleneck. It's about what it takes to actually, you need a lot of compute on those cars to actually utilize it. And I guess a counterpoint to the first mover advantage piece is that there is a safety critical aspect to this. And if you kind of look historically at aviation fleets, actually a lot of them had really serious issues in the beginning, only until certain regulation came into place that allowed the industries to thrive. So there could also be kind of first mover disadvantage in terms of deploying something that might not quite be ready, and then facing quite a lot of problems, as we're now seeing with certain deployments that are happening.
So Vlad, you chose at Helm to start with enhanced ADAS and kind of enter the market that way and grow the capability as regulations catch up. Can you talk a little bit about that strategy?
Yeah, absolutely. It's something that I was thinking deeply about back in say 2016 or so. And if you kind of look at the overall problem, and it is definitely a difficult problem. It's a safety critical application. It requires really cutting edge technology. It requires a substantial amount of validation. And what I can recognize is that if you take a pure play approach, where you're trying to build your first product as an L4 autonomous system, you're going to be facing these significant safety and cost issues that are blocking any revenue from coming in, right? So from a business independence perspective, I actually don't think it's possible to do it that way. And there's also a validation bottleneck as well, because nobody can put up the capital for 1 million cars without tying it to an existing business model. And that's going to be very important, in terms of validation perspective. So the strategy we pursued is high-end ADAS and essentially partnering with automakers, because that way we're able to first build a large, independent, profitable business that's not bottlenecked on L4 deployment. We get to partner with automakers and get access to essentially a large-scale validation framework toward L4 by going into mass production. And even from a scientific and kind of product perspective, attacking the entire problem up front where you're deploying kind of everywhere, you get to see the entire surface area of the problem and figure out the best way to solve that, and then essentially maintain this invariant of a cost-effective solution that has actually scaled and met certain safety requirements. And so the minute that compute platforms, et cetera, catch up, it's essentially a turnkey platform in order to deploy L4.
Great. Now, Taran, kind of talking more about the safety and kind of the optics. So how important are consumer opinions, in your view, on safety versus the opportunities that are created by accelerating and kind of pushing the envelope on this new technology?
Yeah, sure. So I think just to add to Vlad's point, right? So I think a strategy of building consumer confidence, right, with some products, and today it's, for example, ADAS in a sense, right? I think that goes a very, very long way to sort of placate a lot of the optics, a lot of the confidence that the consumer might have towards these technologies. And people should of course push the envelope. For me personally, I think that it's not so much even like a matter of how aggressive companies are or whatnot. It's really about the diversity of different ideas and different techniques and different paradigms that the space is of course trying out. And I think that's important because it's a very safety critical space in that sense, right? So, but totally, I mean, as far as people getting confidence in systems, I think that they should hit the road pretty quick, and I think that that exposure will help them build confidence there.
Can I add an anecdotal story? When I wrote the paper, Self-Driving Cars, the Next Revolution, I think it was like 12 years ago, we researched this topic, and you were talking about the aerospace industry. We went back and found a New York Times article. It's hilarious how some things never changed. First of all, it was in the 1900s, and the Model T was coming, and the biggest issue was with the horses and what the hell to do with all the manure. There was big articles about what are we going to do with all the manure. Yeah. But the most interesting one to me was the farmers. The farmers were livid at these new cars, and talk about resistance back in the day. The farmers were actually shooting at the cars because they were so upset that the cars were scaring the horses. So, we have, some things never change. There's resistance. Over time, this is going to be adopted, but mark my words, I'm sure even in San Francisco you have resistance in people, and each as it plays out, but slowly over time, we'll adopt, and we'll adopt pretty damn quickly, in my view.
Usually regulations are kind of a trailing indicator. But in San Francisco, surprisingly, there's some stories now of Cruise and Waymo having some issues. They're really kind of testing in the city here quite heavily. And there's been some pushback. And the question is that going to be kind of 2 steps forward, 1 step back, or 2 steps back, which kind of does damage to the whole industry overall if you push it a little too fast?
Well, my view is there's going to be friction no matter what. And there's never 100 and 0. Some people are, we did a lot of research studies early on people's opinion on this. There are people in the population that will never, and they use the word never, get into a self-driving car. They wouldn't trust it. There's X%. So I think you'll have some resistance always, and the industry will have to adapt and adopt and kind of maneuver it.
Great.
There's one interesting anecdote I remember back when I used to work on this, was that we used to have this thing called the mom test, which is like, okay, would you put your mom in the car? But I was a lot more thorough. It's like, no, would you put your mom in front of the car? And if you say sure, then I think then the bar is met in the sense.
That's right? The next level of the trolley.
That's the next
trolley
right.
test, right? Very good. Well, we have a minute left, and I wanted to give a quick lightning round. So 5 words or less. Or fewer, I should say. We'll start with Vlad. Does autonomy hype help or hurt the industry?
I think it actually hurt the industry, but I think we're now kind of past that in some sense.
Gary?
I agree with Vlad.
I think hype definitely hurts the industry.
Hurts, okay.
Yep.
In 10 years, who will be the bigger company? Cruise, Waymo, or Uber?
Uber.
They're all our great clients, so I'm going to be the politically incorrect. We love all of you.
Lyft then, yeah?
McDonald's?
McDonald's. Okay, this is going to be an interesting one. What car are you driving now, Vlad?
Oh, it's embarrassing. I have a Kia Niro, but there's a good story for why. So, yeah.
Kia Niro. Gary?
I have a badass Bronco and a Model X.
Okay.
I drive a Honda, but if I were to get a second one, it would probably be the H1 Hummer.
H1 Hummer.
Yeah,
Okay. All right. Rivian over here.
that's right.
Oh, Rivian, very good.
Rivian. Yeah. And Vlad, finally, last question. We're out of time. Quickly, when do you think we will lose the steering wheel?
By 2030.
2030? Gary?
Even on robotaxis, even earlier.
Okay. Taryn?
Oh, that's always a tough one. I think it might take some time.
After 2030?
Sure.
Over?
Sure, but
Okay.
maybe not by that much.
Okay.
Yeah.
2031.
Let's say.
Thank you very much, everyone. It's our time.